Alright, we have just discussed an extra example on finding area between two curves. And notice that for the earlier example, we integrate the top graph minus away the bottom graph with respect to x. But now let us look at this extra example 2. Determine the area of the region bounded by these two curves. In other words, we need to find what is the area of this shaded portion. Think about it, if we are going to integrate with respect to x, how are we going to do, and is it very difficult to solve? If we are going to integrate with respect to x, then we have to determine who is the top graph and who is the bottom graph. And in this case, it's very difficult to identify who is the top graph and who is the bottom graph, because there are different segments in which the red graph could be the top graph, or the red graph could be the bottom graph. The same goes for the blue graph. So if you want to integrate with respect to x, then essentially we are looking at three different parts. Part 1 is right here. Let's call it region A. Part 2, we are looking at this part, B. And the third part would be region C. So how do I know that I need to separate them into these three parts? Because I need to identify who is the upper curve and who is the lower curve. In this case, let's look at region A. Region A, this part here in orange is the upper curve, and this part here in green is the lower curve. So if we want to integrate with respect to x, finding region A, we need the equation of this orange portion of the curve and as well as the green portion of the curve. The same thing goes for region B. For region B, the upper curve is this portion here, and the lower curve is this portion. So the same thing goes, I need to find the equation of this graph, y being in terms of x, as well as this graph. Last but not least, for region C, I need to find out what is this portion of the graph as well. This is the upper curve, and this is the lower curve in green. So I need the equation of this graph, I need the equation of this graph. So based on my explanation, I think you can sense that by integrating with respect to x, it's not going to be an easy job, because you have many things to worry about. Who is the upper curve and who is the lower curve? To find the area of this region, it is not necessary that we always need to integrate with respect to x. There's an easier approach, which is to integrate with respect to y. Let me explain. To integrate with respect to y, I need to identify where is the rightmost curve and where is the leftmost curve. So the rightmost curve is quite obvious. This is the rightmost curve, and this is the leftmost. And there's only one region to worry about, which is this whole shaded part, because I just need to identify what is the y value here and what is the y value here. And this is clearly the rightmost curve, and this is clearly the leftmost curve. However, before solving for the area, we need to identify the y coordinate of the intersection point. In other words, the lower limit of the integral and the upper limit of the integral. In other words, I need to find the y coordinate of these two intersection points. So to find the y coordinate, I allow the two graphs to intersect. Now I will have negative y squared plus 10 is equivalent to y minus 2 squared. Right, solving, you will have this. Y being negative 1 or 3. In other words, this is negative 1 and this is 3. So the area would be integral from negative 1 to 3 of the rightmost curve, which is negative y squared plus 10, minus away the leftmost curve, which is y minus 2 whole thing square dy. So solving, you should have no issue getting the answer 64 over 3. Please go and try and check whether your answer is indeed 64 over 3.